In today's video, we're going to take a close look at this RigExpert AA-55 zoom antenna analyzer, really kind of geared towards the radio amateur who likes operating in HF and the 6 meter frequency bands. As the 55 stands for 55 megahertz, which is the upper frequency range of this analyzer. RigExpert makes about 10 different models of analyzers that range from a max frequency of 30 megahertz up to 1400 megahertz or 1.4 gigahertz. Now, we should more accurately call this unit a multifunction antenna and cable analyzer because it really is a lot more than simply an antenna analyzer. Let's go take a look at what I mean by that. I'll do a quick rundown of the various measurements you can make with this AA-55 zoom. We've got the ability to plot the complex impedance versus frequency on a Smith chart, as well as plotting SWR versus frequency on a traditional SWR sweep. Plot just complex impedance versus frequency, the real and reactive components. The SWR meter is a single frequency SWR meter that has a couple of interesting modes in it. All params is a way of looking at everything from the SWR, return loss, complex impedance, etc. at a given frequency. The setup function allows you to go in and set up the language, the units, whether you want it to be imperial units or metric units, set up frequency bands, amateur radio frequency bands to be in the Americas or Europe and other parts of the world. There's a Calibrate function that allows you to do a full vector calibration so that you can establish a reference plane either at the instrument's connector or maybe at the end of a piece of coax, so you can actually make measurements referred to the antenna feed point impedance. You can also sweep return loss versus frequency. The multi-SWR function allows you to measure SWR at multiple frequencies, really handy when you're trying to tune a multi-band antenna and looking for the interaction between tuning one band and seeing its reaction on another band. And there are some additional tools for coax measurements which can be really handy. A Stub Tuner that allows you to measure and tune particular lengths for quarter wave and a half wavelength long hunks of coax or stubs of coax. You can also measure the length and velocity factor of coax, and also sweep the cable loss and cable impedance versus frequency. So lots of functionality and actually very easy to use. If you take a look at the icons here on the left hand side, the number is associated with the keypad number. So for the Smith chart we would just hit number 2, and you see that key number 2 says polar, and that's essentially the Smith chart. If you want to do an SWR chart, you could just hit the number 4 and it says SWR right there. The real and imaginary impedance plot is key number 5, etc. So it's very, very easy to figure out what to do. And also, no matter where you are in a measurement or things like that, the 1 key is generally a help key, and it tells you so right here. If you hit 1, it actually gives you help, and you can scroll through and get help about what these various keys do. So you don't even have to crack the manual open, even though the manual is actually very well written. I've got access to a 20 meter antenna down here in the basement shack, so let me hook that up to the analyzer here, and we'll run through some of the measurements that we can make on this antenna. Let's start off with the very basic SWR chart. So I'll select that by either hitting 4 or arrowing up and down until I select that item and hitting OK. And right now I've got it set to sweep with a center frequency of 27.5 megahertz and a sweep 27.5 on either side, so it's the full range sweep. And if I hit OK, we're sweeping that full range of the antenna. Now what you can see on this sweep are these various colored bands. Each of these colored blue bars represent amateur radio bands. In this case I've got it set for the US and North America amateur radio bands. And we can actually see we've got a dip in the SWR right here on this band, which happens to be the 20 meter band. In fact, the minimum is being shown here at about 14,360, just outside the amateur radio band about 1.89. Now any of the plots that are made on the analyzer itself consist of just 100 points. So it's likely that there's a lot more going on in here. Now we can tune the analyzer a number of different ways. Just by hitting the frequency up and down keys, I can shift our measurement frequency, and then the up and down keys here will change the range. So I can zoom in on a particular area, so I can center that again and zoom in again, And then I can go and repeat the measurement and do another 100-point sweep right there. So now I can actually see I've got a little bit better granularity in the 20-meter band, and I can actually see that the minimum is sitting inside the 20-meter band. Just as an example of some of the other functions that are available to you, we'll hit the help key here. So you can do, you can just have it run once and stop by hitting the check like we've been doing. If we hit the function and checkbox, it'll continuously cycle and continue running until we hit the stop key. 0 will show the data at the cursors, and I'll show you what I mean by that. So I've got the cursor sitting right here. If I hit the 0 key, it shows me the SWR, the complex impedance and its phase, the return loss, as well as the complex impedance values that are there. Some other interesting things, let's scroll down to the next page of help. I can change frequency like I was showing you using the frequency keys back and forth, change the range by hitting the range up and down keys. The 3 key will actually allow me to enter frequencies directly a couple of different ways. We'll look at that next. And then the function in 3 key will restore you back to the full sweep of the analyzer again. Oh, and one more page on help here. Hitting the function and the side arrows will jump you to the minimum SWR. So that's really handy to, if you see where the minimum is, I could jump to that frequency, then zoom in around that. The function up and down keys will change the scale or vertical scale on the plot. We can also save or load data, so you can actually save traces that you've made on previous measurements, even edit those names. So a lot of functionality that's available here. So if I hit the function and arrow keys, I can jump right to where that minimum is and then re-perform a sweep right there again. If I hit the 3 key, that allows me to go change frequencies directly. I can tell it what center frequency I want and how much I want to sweep around that. Again, hitting the function and 3 key will do the full range, but also hitting the function key allows me to now scroll up and down through the various amateur radio bands. So the 20-meter band is centered at 14.175, and then plus or minus 175 kilohertz around that. The 30-meter band is here. So if I only want to sweep just the 20-meter band, I could just select that, hit OK, and now if I sweep that, now I'm sweeping my antenna just over the 20-meter amateur radio band. If I want to go a little bit wider, I can just open up the scale and then sweep again. And again, if we move the frequency back and forth, essentially our little vertical bar here is where we're making a measurement. So in this case, if I move it over at this particular vertical bar, I can see the SWR is 1.87. If I hit the data key, I can see there's the SWR and all of the other numeric values associated with that particular measurement. Now once we've made a sweep, we can look at it in a number of different formats. For example, if I hit the polar key, or key number 2, that brings me to the Smith chart. And here's the Smith chart now of this particular antenna impedance versus frequency. You can see the little red square here. That's essentially at this frequency here, 14.215. And by hitting the frequency arrow keys, we can move that around and see where we are in the Smith chart at different frequencies. Similarly, we can hit the R, X key, key number 5, and that brings me to the complex or the real and imaginary components of this antenna. If I hit the function and range up and down keys, I can change the scale of the measurement that we're looking at here. Instead of being plus or minus 1,000 ohms, we can knock that down to look at even a finer scale to look at the real and imaginary components of the complex impedance looking into this coax. The function 4 key will take us from the SWR plot to the return loss plot. Just another representation of essentially impedance match, and essentially we want the return loss to be as high as possible when the SWR is low as possible. So we can actually see we get return loss here of about 15 or so, 14.8 at 14.24 megahertz. So those 4 measurements, the Smith chart, SWR return loss, and complex impedance sweeps, are all kind of the swept measurements that you can make with this antenna analyzer. But there's a number of other measurements we can make which are equally useful. So if we hit the 7 key, or the SWR key, we'll get essentially a SWR meter. And by hitting the OK checkmark key here, we can start the meter reading. That's what the flashing indicator means here. And this shows us our measurement frequency, graphically and numerically showing the SWR as well as showing the return loss. Again, I can hit the frequency keys to move up and down in frequency and see how the SWR changes at different frequencies. And if I use the function and arrow keys, we can move the frequency in larger steps. And of course, hitting the frequency and range key, we can actually dial in a frequency directly if we want to do that. But there's some other interesting capability here. Let's take a look at the help key and see what I'm talking about. So we talked about how to change frequency and set frequency, start and stop the meter. But there's also this function here called SWR to air. This is actually a very interesting feature. Let's look at that right now. The SWR to air feature is really useful when the analyzer is sitting in a spot where you can't see it when you're making adjustments on the antenna. It could be that the analyzer is sitting at the end of a coax, maybe inside your vehicle or inside your Radio Shack, and you're outside making physical adjustments to the antenna, and you can't see what the meter reading is saying. So the SWR to air function basically will transmit a code to tell you what is going on with the SWR as you're making adjustments to your antenna. You set the SWR to air transmit frequency using the function 3 key, and then you start this up. Let me show you what that looks like. Now, I've already set the SWR to air transmit frequency to 144.500 megahertz, so I can hear it on this little handy talkie. So I could stick this thing in my back pocket when I'm making adjustments to the antenna, and then in order to enable this function, I hit the function and checkmark key. So let's actually go do that. So I hit the function and checkmark. You hear one short beep coming out of the radio. So the single beep tells us that we're in the 1 to 1.0 to 1.99 SWR range. As we go higher in SWR, the duration of that beep gets longer. So we can hear now that we're at 1.76, 1.77, 1.8. The length of that beep is longer than it was down here. See, it's a nice short beep now that we're below 1.5 to 1. If we go even higher in frequency, we get into the 2s. It's transmitting 2 beeps. Okay? We get into the 3s and above, it transmits 3 or 4 beeps to tell us that we're way out in SWR. So by listening to these beeps and how many are being transmitted and then the duration of them, we can see how our SWR is doing remotely without having to actually be seeing what the meter is doing. Now, another handy feature for the single frequency SWR measurement is the heartbeat display, and that display is entered by hitting the function and up arrow. So if I hit the function up arrow here, we get this heartbeat display. And what this is kind of like a scrolling, almost like a heartbeat monitor, which is why it's called that. So as the SWR changes, this bar graph changes. So let's see if I can adjust frequency up and down. We can actually see the SWR changing because I'm changing frequency. So we can tell by looking at this bar graph very quickly if I'm making adjustments in the right direction, either with an antenna tuner or by actually tuning my antenna physically. So it's another easy way to kind of monitor how the changes that you're making to the antenna or your antenna tuner are affecting the SWR. Now, an interesting variation on the single frequency SWR meter is the multi-SWR measurement. We hit the function and 7 key. We look at the multi-SWR measurement. Now, this is allowing us to look at SWR measurements on multiple frequencies essentially at the same time. Now we can see in this case I've got a single band antenna, so I've got good SWR on the 20 meter band but very bad SWR on all the others. But if we were looking at a multi-band antenna like a trap dipole or a multi-band vertical, oftentimes when you're making adjustments on one band, it will affect the other bands slightly. So this will allow you to kind of see the effect on all of the bands as you're making band-specific adjustments on that antenna. Very handy feature. Now, in addition to this numeric mode for the multi-SWR, we'll also see that there's a graph mode that's entered by hitting the function and up key. So we go and hit the function up and hit OK to run. We essentially get a little graph of each one. So instead of actually looking at the numbers, you can actually see what the SWR sweep is doing in each of those particular bands. And of course, you've got the ability, no matter which mode you're in here, to make adjustments to what frequency it is that you're looking at on each of those bands. And finally, the all function, character or key number 8, will allow me to actually get live measurements of SWR, complex impedance and phase, return loss, as well as the complex impedance and the capacitive and inductive components measured kind of live. And again, we can adjust frequency and watch those things change. So as we've seen, this is a very comprehensive analyzer for looking at antenna mismatch and SWR conditions, complex impedance conditions for both swept as well as fixed and multi-frequencies. Very handy analyzer. Let's take a look at some of the other tools for doing some measurements on coax. Next we'll take a look at some of the coax measurement tools that we have. If we hit OK under Tools, the first one is the Stub Tuner. This tool allows us to determine the half wavelength and quarter wavelength lengths of coax. So if I hit OK on this, it tells me to connect the cable with an open or short at the far end and then press the check mark to start. So I've got this hunk of cable here that's open at the far end, and what it's telling me is that this hunk of cable is a quarter wavelength long at a frequency of 5.24 megahertz, and it's a half wavelength long at 12.6 megahertz. And again, these could be handy values because what we know from coax is that, or transmission lines, is that if you use a half wavelength at a given frequency, the impedance seen at the feed point of the coax is exactly the same as the feed point or the impedance that is present at the far end. The quarter wavelength moves us halfway around the Smith chart, essentially gives us the complex or the inverse of the impedance. So this very easily allows us to determine quarter wave and half wavelength lengths of coax. The next tool allows us to determine either the length or velocity factor. If you know one, you can determine the other. So in our case here, we know the velocity factor of this coax is 0.66, but I don't know the length, so I'll hit the check mark here to go measure the length. And it actually measures that length of 24.87. In this case it's feet, because I've set the analyzer to use imperial units, because that's what I use here in the US. But you could also set it to measure in meters. Now if you knew the length but you didn't know the velocity factor, you could dial in the length and actually measure the velocity factor. Now the cable loss tool allows us to measure the loss of the coax versus frequency. We start off by leaving the far end open and hit the check mark. It collects a little bit of data. Then it's going to ask us to connect up a short to the far end of the cable, which I'm doing now, and hit the OK key. Oops, hold on, let me get my short on there. Hit the OK key. We'll make some measurements on the short, and then we get the plot of loss versus frequency, and we can move our frequency back and forth to measure loss at any given frequency here. And once we've done that sweep, we can also then switch to the cable impedance tool and hit OK, and we've automatically got the results of that. And that's going to show us our coax impedance versus frequency. Now in this case you're going to see these little disturbances that are going to occur every quarter wavelength, just because of the way the impedance inverts at the quarter wavelength boundaries. But we can see that this coax is a little bit closer to 55 or 60 ohms as opposed to 50 ohms. This is an old piece of dried out coax here, so I'm not too surprised that it's not closer to 50 ohms, but very easy to get those results as well. Let's talk a little bit about the calibrate function. Of course the instrument comes fully calibrated, and the measurement plane or reference point is essentially at the connector on the top of the analyzer, so that the SWR and complex impedance is what's being seen right here. Now if you're trying to design maybe a matching circuit to fit at the base of an antenna, you really want to measure the complex impedance at the antenna feed point, not here. But if you connect up a piece of coax, the impedance seen here is not going to be the same as it is over at the antenna. So you can use a Smith chart and things like that to figure it out, or you can actually use the Calibrate function to establish a reference plane at the far end of the coax. Let me show you how you do that. So just as an example, let's do a Smith chart real quick without anything connected here, so we just have an open circuit. And we can see that the results are all right here, essentially at the open circuit location on the Smith chart. Now I've connected up a short, 5 or 6 foot length of coax here, and let's run the Smith chart again. We can actually see that we're rotating essentially around the Smith chart. We went part of the way away from our open circuit point, And then as the frequency ramps up, we're going a little bit further. So that now I've got the end of the coax open, so really from the end of the coax, all the points should wind up right here, but because the coax transforms the impedance, we're actually moving around the Smith chart. But if I wanted to measure the impedance that appears at the far end of my coax, I need to establish the far end of the coax as the new measurement reference point. That's what we'll do with calibration. Okay, so we'll exit out of the Smith chart and scroll down to select Calibrate, and I'll hit check mark to start the calibration, and it's just telling me to prepare my open, load, and short for calibration standards, which I have right here, and we'll get ready to start. And the first thing we do is connect our calibrated open to our end of the coax and hit the check mark to run that portion of the calibration. It's collecting some data. And then we connect the short to the end of the coax here, and that's this guy right here. And then we'll hit the check mark again once I've got that tightened up. And then finally, after this is done, we connect our 50 ohm load to the end of the coax here and grab data there. And once we've done that, we've collected all of the information we need to actually run the calibrations, and we hit function F2 to activate and deactivate the calibration for the measurement. Let's go look at how that affects what we saw on the Smith chart. Now remember, here's our Smith chart result that we got without calibrating to the end of the cable. By hitting the function 2 key, we can actually apply the calibration. And now if we take a look, all of our measurement points are right at the open. If I hit run again, you can just kind of see it all updating right there. So now we've got an open at the end of this length of coax, and we're actually accurately showing that on the Smith chart. So now any load that we connect here could be our antenna. What we're going to see on the Smith chart and all of the other swept measurements are going to be with respect to this location at the end of the cable. Now, as I mentioned at the beginning of the video, all of the swept measurements, whether they're Smith charts or SWR plots or things like that, will give you essentially 100 points across the frequency range that you're sweeping. You do have the option of connecting the analyzer up via USB port to a PC, and RigExpert has software that allows you to repeat all these same measurements on the PC with up to 1,000 points in the sweep. So that could be a really handy way to get more high resolution data if you need that. Now, but the only thing we really didn't cover so far were some of the setup options. So this is where you can set the language. I've got it set to English. The color palette I've got set to orange, which is really kind of this multicolor thing we've been looking at. But there are two monochrome black and white type of displays. For high contrast is a white background with black text and things like that. Probably would work well outdoors when you've got bright sunlight. But then also you can also do the inverse of that as well. Still a black and white, but with now inverse of the other one. But the multicolor one is pretty pleasant to look at. Battery, this kind of controls when the screen will go dim and when the unit will go back to sleep. I had been running it for the video here mainly on intensive, so the display wouldn't go dim while I was doing any filming here, but under normal operation I usually leave it under optimal. Sound turns on or off as sound associated with the key presses on the membrane keypad. Again, I turned it off because I didn't want it beeping while I was doing the video here. System impedance allows you to select what system impedance you're actually dealing with. In most cases we're going to be dealing with 50 ohms, but you might be dealing with 75 ohm coax and a 75 ohm system. You can actually make all your measurements with respect to 75 ohms, SWR measurements, reference a Smith chart to that, as well as all the way up to 600 ohm ladder line feed, so whatever you're typically using. But we'll use 50 ohms in our particular case. Units again can be imperial or metric. I've got it set to imperial because I'm here in the US. The bands allows you to select the amateur radio bands for different parts of the world to make it easy to select a particular band to do measurements on. And then the default cable velocity factor, in most cases we're using kind of foam dielectric, which is a 0.66 dielectric. Any frequency correction if there's any errors you want to correct. And then you could also reset all the settings back to factory defaults. As I did mention, anytime you make a sweep, you can actually save those sweeps to look at SWR and Smith charts and things like that, at a later date. If you wanted to clear all those saved charts, you can do that right from here as well. I hope you enjoyed this review of this RigExpert AA-55 zoom. I think a really versatile analyzer, very, very easy to use. Lots of ways of getting help. The on-screen icons tell you what keys do what. The keys are actually clearly labeled to what they do for both their primary function and their shifted or F function of those keys. The help key will also give you a lot of information about how to set various parameters and do various functions within any of the particular measurements. So again, a real handy analyzer. I don't do a lot of product reviews, but those that I do, I do on products that I really enjoy, and I think this is going to be really a fantastic analyzer for my antenna experiments. So thanks again for watching. If you like what you see, give me a thumbs up. If you haven't subscribed to the channel already, please do so, and go check out the RigExpert line of antenna and cable analyzers. Really a lot of value for the money, I think. Take care and see you next time.